Leslie, we can even see you, and I see you did your makeup and your hair.
Oh, good. Even my earrings.
Yeah.
Finally finding my way into the crowd. Hello,
Okay.
John, and hello, Irvin. It's good to be here. Thank you. Thanks for linking me up.
Okay. All right. John Ward, you ready to go?
Yep, I guess let's give it a go.
Right. Good morning, everyone. I'd just like to do a very brief introduction of John Ward. I think many of you know him well. I see there's a really good contingent of diamond people on the talk today, so welcome to everyone. John is a University of Natal graduate, glad to say, so he's balancing out our different alma maters again. That's where he studied. He then worked at De Beers for 16 years and got good grounding and training there, like many of us. He resigned in 2000. And he's been a private consultant and also worked for a number of the mid-tier junior companies, including, for example, Gem Diamonds. And he's currently with Namibia Diamonds, as well as doing a few other things. So thanks for making yourself available, John. I know you're a busy guy in spite of the lockdown, and we look forward to your presentation. Thanks very much.
Thanks very much, John, and good morning to everyone. Great to see some of the old mates out there, still interested in diamonds in spite of the market cuffing us at the moment. So really, what I'm doing today is certainly nothing new. It's something that's run in the blood for many decades, and that's the alluvial side of the diamond business. And what I want to do is just refresh our memories as to how good the placer deposits and the Namibian mega placer deposit in particular is, in terms of a global standard. It really does set the scene. It's in a class of its own. And what I'll do this morning is run through the work that Mike DeWitt, and Mike, hopefully, is on the line because he'll take the questions afterwards. And the late Professor Brian Bluff. We put this together in 2005, was published in, so it is available in a global context. And really what I want to do is just take us through it and just remind ourselves that how great the placer deposit it is, and also the interplay of the different features of making models and trying to get a better understanding, particularly of our African diamond deposits, both the primaries and the secondaries, because we've been doing a lot more work in Central Africa in the last 2 decades, and this has really helped on that. So there's obviously due acknowledgements to the work that was done during our time in De Beers, and they sponsored Brian on many of those trips. Right. So basically what I'll do is give us a little bit of diamond jargon, but most of us are in it. And then a mega placer definition, just to remind us. And then looking at Africa in a 2019 context, obviously pre-COVID, because things are pretty tough this year, as we all know. And then we'll take us through the source to sink placer model, how we develop that. And then where the Namibian mega placer fits in terms of the source to sink model. Right, so some of the jargon really is that in Africa, our primary sources, our primary origin for the diamonds are kimberlites. There are a few in the Luangwa Valley that are lamproites. And Bob Burrell knows those well from his early days in De Beers there. And obviously out of the primaries, they get eroded into our secondary and alluvial deposits. And the focus of placers obviously is going to be on the alluvial deposits. In terms of diamond measurements, we all know it's pretty hard, 10 top of the scale. We talk about carats, 0.2 of a gram, pretty small, the carats. Our size, we talk about carats per stone. And then the diamond sieves, they have their own league, to be honest. The plus 11s and the plus 21s and all those sort of things that come out there that we use in statistics to define the populations. But that's part of the jargon, and you really have to know it. And extremely useful in discerning different populations both in the primary kimberlites as well as in secondary deposits. Obviously, the diamond content is the grade, and we measure the mass in carats per ton or carats per 100 tons, particularly in South Africa, Southern Africa, where our grades are low. We tend to talk about 100 carats per 100 tons, whereas up in Central Africa, it's invariably carats per ton, believe it or not. And or we talk in volumes, carats per cubic meter, or not well used in South Africa, the carats per cubic meter, more common in Central Africa, and mainly because our metallurgists think they know better than the rest of us. But yeah, there's a grade is in our diamond deposits generally is in parts per billion. I think we all know that. We know how difficult it is to determine grade, particularly in our low grade, our 0.3s and our 0.5 carats per 100 ton that we've spoken about in the past. The next bit of jargon is really our revenue. The diamond revenue is recorded in dollars per carat, and no diamonds being the same, or very rarely, it certainly it adds to the mystique and to the expertise that is required in determining what your rough prices are, that are going to be. I'm not dealing at all with the downstream end. I only worry about the rough side of the stones. And therefore, overall, I think it's no surprise to any of us that our diamond deposits, both primary and secondary, are extremely difficult to evaluate, because you need big chunks of the material to source enough diamonds to get a decent population out of it, and that requires money to even get into the starting blocks, never mind get out of the starting blocks. I think it's just to remind us that that's where we are. So what then is a diamond placer? The secondary deposits, we all tend to call them alluvials. They pretty much are all alluvials. And it's a mechanical concentration by the physical processes out there. You know, by our rivers, by the waterfalls, the rapids in particular. It's the washing machines of the natural sedimentary environments, both in the marine environment and in the fluvial environment in particular. There are a couple of others that add to it, an unusual one in the Aeolian, which we'll discuss a bit later, and obviously ice, which is mainly a transporter and hardly a concentrator. So what then is a megaplacer? If we've got diamonds that are concentrated in placers, what's a megaplacer? Well, our 2005 definition with Brian, Mike, and I, we decided it should be a deposit, an alluvial, a secondary deposit that would hold at least 50 million carats at or around between 90 and 90. We use 95% gem quality, but you know, anywhere above 90% gem quality is pretty good. So it's quite a tall order to ask of a natural deposit out there. So in effect, megaplacers are a rare beast. I think one of the things that we're going to have a look at today is just how impressive that Namibian and West Coast placer really is, even in this context of a megaplacer. The other thing to bear in mind is that with the amount of working and reworking and beating the stones around down river systems and through ice and in the marine systems, you knock off the poorer quality goods, and therefore your alluvials in general tend to have a better quality and therefore a higher dollar per carat, higher revenue than your primary sources. And they're often were the targets in the earlier years. If you have a look at when Africa opened up from 1908, from the Speurgebied, 1907, the DRC, Angola, 1917, etc., the focus was on alluvials because that's what the guys were chasing. That's what they were able to find in terms of loose material. It was only really in the 50s in Angola and that when the first kimberlites were discovered, and obviously for us a lot earlier in South Africa. But it's interesting, you know, the alluvials have often led the way to the primaries, and the primaries become easier to work economically because you can put a fence around them, you can work out how much power, how much water you're going to need. Whereas in alluvial, in your placers, you have the famous nugget effect, and you really have to understand your rivers and your marine environments really well to maximize where the concentrations take place. Right. So let's have a look at what 2019 globally looked like in the diamond industry. And if you look at the top 10 there, you can see Russia obviously moved as ousted Botswana in the last few years as the top ranking. This is in dollars, by the way, and we're doing that just because it might help to produce lots of carats. But if they're not worth a lot of money, like an Oz, then you sit at number 10 and not at number 1. And so it's Russia, Botswana, Canada, Angola has moved up the ranks, dropping South Africa back to number 6. Namibia has also moved up the ranks, sitting spot in the middle of the top 10 there at 5. And then Lesotho, small as it is, it's in the top 10. Congo's making a bit of a comeback in there. We don't have the second half figures out of the Kimberley stats, but pretty much doubled the production just to get it there. Sierra Leone pops in and out of the top 10. Then Aussie has been slowly slipping down the ranks and will definitely fall off the map probably by next year with the closing of Argyle. I think it's, that's the top 10. It's been pretty much the top 5, 6 have been the same for quite a few years, and it's the bottom end of the top 10 that have moved in and out. But it's interesting, top 10 is 98% of revenue, 98% of carats. But have a look at Africa. Africa really has 7 in the top 10. That's been like that for a long time now. And this is what's impressive. 41% of the global carats, but 54% of revenue. I think that's really, makes Africa the special place, and we know that. The Cratons, Mike and John Bristow and the boys have all given us talks on that, and it is a special geological context for primary sources. So if we have a look at the diamond occurrences in Africa, just by country now, this is not by mine or venture or operation. If we have a look at from Mike's paper back in 2016. 64% of the global production from the 1800s has been from Africa. It's a fair chunk, 32 billion carats, of which the bulk of that came out of the DRC, actually. And that's from Bujimai, we all know that. But it's moving on to 2019 and revenue, because really it is all about revenue. It's what you're going to get for your stones, and what your deposit is worth in the ground is largely determined by grade and by what you're going to get out of your stones. So the global average is running around about 100 at the moment, and Africa is sitting 29% above that. That's pretty good going. Whereas the other three, Aussie and Canada and Russia are somewhat below that, below the average. What is interesting is that most of the countries are related to primary sources. Yeah, everybody has a few alluvial occurrences on it, but most of the producers or most of the countries are associated with primaries as well as alluvials. And there's Namibia sitting in the middle of the top 10, and it doesn't have any primaries to talk of. And we know that. It's well off the Craton, and it's also our number 1 in the world in terms of average dollar per carat, sitting at 500. And this is what really leads one to start to understand or want to understand this a lot better. It was found in 1908. Fred Cornell really sort of recognized that some of the gravels were coming down the Orange over here, but there were lots of arguments in those early years with the kimberlites offshore, etc., etc. Obviously, life's moved on a lot since those days, and our understanding of the distribution of alluvials and kimberlites in sub-Saharan Africa in particular is pretty good now. There's not too many new discoveries coming out. Let's be honest, we know that because the exploration has been cut back in those countries. But if we have a look at this map here, the green stars are the kimberlites, the purple triangles are the alluvials, and we all know that there's a very strong relationship between metamorphous kimberlites and the cratons. There are obviously those that are off Craton over here, lots of Angola, but this sort of pattern of alluvials and kimberlites, Angola, CAR not having any primaries that we know of at least. And then Namibia sitting down here with this long tail running from the Namaqualand side of South Africa all the way up the coast, bit of a gap over here, and Wolf is picking up again the Skeleton Coast in Namibia. Nearly 2,000 kilometers worth of diamonds over here, quite impressive in the alluvial sense. And it was really looking at this that we spent some time in the 90s trying to build a model that would help us in the exploration side in particular, as Africa and Angola was reopening again in the late 90s. So if we have a look at from the poster series of Maggie Newman, which is just great, we've got our primary bodies, everybody knows those. They get eroded. Some of the sediments stay inside the pipes, but when you can leak it out the pipes, they get moved out and down into the natural sedimentary systems. And the principal mechanism is really fluvial. You've got our rivers that do most of that, and that's mainly because rivers are the main drainage features of Africa in particular. We've also got the glacial signature, which obviously in our case is Dwicker is the most important one, and we saw that in Mike's recent paper on Lichtenberg, and also then marine and aeolian in Africa, which makes it pretty special because this doesn't happen too easily in the world. We also know that our diamonds are really they just class in a sedimentary system. You know, if you stand back and look at it, a special class, they get paid a lot more for them than you do for quartz, let's be honest. But they also can take a beating, as you can see here. This is the same. This is an aqueduct alluvial deposit near Kimberley. Here are the fresh stones coming in out of the Kimberley pipes, typical Cape Yellows, nice octa shapes. And here's some braided stones that we've tracked back. In fact, it was Debbie Bone who's on the line. She recognized these on the West Coast way back in the 90s. Not that it says you're very old, Debbie, but anyway. And these stones we've now tracked back to the Northwest Province in the Southern Diamond Field. So they just class, you know, and if you look at those and try and understand the features, Jeff Harris has done a lot of work, and Ray Phillips and lots of other people, Ingrid Chin, Farnes Fulun, lots. I'm talking about the African context now. And if we have a look here, we find there's a very nice diamonds down on the coast. And one of the things about the diamonds is that, again, like normal class assemblage, close to source, bigger stones, further from source, smaller diamonds. And this pattern is, you know, it's just part of the system. But as we all know, diamonds are rare. And so what we tend to do is look for the associates that go with them in our travels. And this is really clear in the Orange River. There's a very distinctive class assemblage that's associated with the diamonds. And we'll touch on this a bit later from the good work that Jürgen Jacob did. So taking these elements into consideration, we then came up with a decent cartoon. We believe it's a reasonably robust source-to-sink cartoon for Africa, where our African cratons tend to have subdued topography. They host our primary sources. It's obviously the elephant country of Clifford's rule, and it's on these cratons is where we have the proximal places. In other words, the places that are closest to source. And as we move off most of our cratons have the welded together by orogenic belts, or quite widely so in some places, but the orogenic belts can be breached by drainages from the cratons that go down to sinks, and the ultimate sink being obviously the oceans and the marine environments. So we have a source to sink with places sitting in the different positions, and we tend to call these proximal places, close to source, transient places moving through the orogenic belts, getting down onto a coastal plain, and where everything ends, the ultimate being the marine environment, then we have a terminal placid. So really, that's what it is. So what we'll do now is take a closer look at our source to sink model, and where it's been particularly well developed is obviously in Southern Africa, because we know a lot about it. There's been lots of exploration, lots of kimberlites discovered, lots of alluvial activity along the coast, and what is interesting, and the work that Mike did for his PhD in that showed the pre-Karoo River and the Karoo River, and then the later developments, is that we have a main source in the Vaal Orange catchment on the Kaapvaal Craton, and 36% of this drainage is covered on this craton, and that's the most in the world. So that's the first thing that's interesting. You've got a big source area on cratons, on diamondiferous cratons, that have a long history of kimberlite intrusions dating back to Kuruman bodies and the Cullinan, of course, you know, those ones all the way through to the young Cretaceous parts of Kimberley. And obviously in the source areas, you have a lower gem quality, and if you can beat it and take it through systems, down through a fluvial conveyor system, as it were, in it, via the Orange, gets into the marine environment, you have a marine conveyor that beats the heck out of it, and then finally a bit of aeolian redistribution and sorting over there, and you end up with, you know, maybe 10, 15% gem quality in the interior, and it going through to 95% gem quality down in this sink over here. That's quite a useful look at it. So let's just have a look now. Let's take a walk, as it were, flight, as it were, from our proximal classes on the craton down through the transient classes, through the orogenic belts, and down onto the coastal plain. And we'll start off now with the interior on the source, on the craton itself. And what's interesting about South Africa, and again, you know, I'm talking to the converted, I know, but one of the things to bear in mind is that we don't have a heck of a lot of crater facies left in South Africa, because mainly it's been chopped off and taken away. Whereas in Angola, this is up in Katoka, this is in Madui, for example, and those ones there, we still have really good preservation. So we have lots of alluvial diamonds in Angola and Congo, but they tend to be proximal to the sources. They're still poking off quite close by. Whereas in South Africa, you certainly cut the top of these off. And so how then do you retain places if there's been a lot of erosion on the interior of South Africa? And obviously that level of erosion has been bandied around from Barry Hawthorne's models days to, you know, 1.5 kilometers, or half a kilometer, or whatever it is. Certainly the work that was done more recently by Hansen at Rhodes, and that shows work that we've done looking at levels, looks like half a kilometer, 800 meters, maybe a kilometer in places, not necessarily 1.5 kilometers. But nonetheless, big erosion, and therefore, how do you keep alluvial deposits on the craton? And one of the more remarkable ways to do it is the topography. So where we've got a platform carbonate over the Archean basement, such as we have in the Lichtenberg area, the old Western Transvaal, in sinkholes that are developed there in the dolomites, in the carbonates, they retain those gravels. And Mike's paper recently shows that these are going to be predominantly Dwicker age deposits, 300 odd million plus. So we're looking at older sources for those. And the other way, of course, is in the southern diamond field, the northwest alluvials, where we've got extensive Roy copy gravels parking off on the interflues, and in the drainages, the shallow drainages there, we have some transient places which are busy taking off these retained places of the Roy copies down into the Vaal system. So that's what we have, you know, on the South African craton. And those of us that have dealt with these, you'll know that the younger ones are calcified. The older Roy copies are Roy copy for a reason. They've been pretty much just red and oxidized and not cemented, which makes it a low-grade deposits that they are, easier to access. So that's pretty much, you know, what we're dealing with in the interior. Not huge places, you know, maybe 10, well, we know that Lichtenberg was over 20 million, well, about 20 odd million at the end of the day. And the Vaal River is, you know, Vaal and mid-orange really comes into the transient portion over here. Again, a couple of million carats, certainly not hitting any mega placer status at this stage. So what we'll do now is have a look at the transient belt, ripping the interior of South Africa out. And this is what the Orange River effectively does. The Vaal Orange is a long-lived drainage system. It had an outfall into the, excuse my spelling there, in the Cretaceous. Changed that this morning. But the Kudu Delta shows very clearly that had a clay and sand outfall around about 100 odd million years ago. And the Orange system was therefore in place so that when we had this end Cretaceous early tertiary uplift, we then imparted energy to this river system, which then stripped out the interior of South Africa. And we know that because we look at the meander loops that are preserved, that are incised into the bedrock. These are 10-kilometer scale meander loops. It was a really big system back in the Cretaceous. And this effectively, with the uplift, got branded into the bedrock and preserved that old legacy for us. But in the meantime, the system changed from gravel to sand, and that enabled the diamonds to be moved from an interior craton craton proximal source all the way down to a terminal placer. And what it did as well, and here's part of it, this is the Fish River Orange confluence. You can see the inherited meanders on the Fish as well. But what it did do is that within 150 kilometers of the distal end of a river that normally would have ended in a big flat delta, is you've got a mountain chain, a mountain belt rather, and this mountain belt is steep. It's shedding coarse material into a river very close to its dying in stages. And these gravels that come out of here are very resistant. They're normal quartzites, and they act as trap sites and also an abrasive medium for when they get into that marine environment to be able to whack your coastal platforms. And I think this is quite important for what we're going to see. And then the classic work that Jürgen Jacob and Brian and I did back in the 90s was just defining the different areas in your transient placers, your scours, your push bars, your bedrock hides, etc. We all know those. And they they're really well demarcated in that lower orange transient placer system. The other thing that we noticed down here out of the Richtersveld is that we have a series of terraces which record the age of this incision and development of the Orange River from the Kudu Delta times through the last 50-odd million years. And terraces young down towards the modern river, and what we're able to link is some of the class assemblages from the interior of South Africa. I'll touch on that a bit later, to the marine deposits of the Eocene age, 40-odd million odd age in the Spurgebied over there. So that's been pretty neat linking that lot together. Been well known for a long time, but it's just nice putting it all together into a model. And it's obviously once you get down onto that coastal plain and you get the influence of aggradation from sea level changes, eustatic changes, then you can start to build up some form of placer deposits like we've got along the lower orange on both sides of the border, the South African side and the Namibian side over there. Gabaras and Algis and Barken, pretty famous deposits, but again, less than 10 million carats, but lovely big stones down this close to the coast and along 2,000 odd kilometers away from the most proximal sources. So this is a big sedimentary fluvial conveyor system. It's certainly on a big scale. It's not a 10 kilometer or a couple of 100 kilometer long scale. We're talking moving into the 1,000 kilometer plus scale. So that gets us then down onto the coastal plain, through the coastal plain, and then onto the ultimate terminal placer, which is where the fluvial conduit effectively outfalls into the marine environment. And here we have a littoral situation. It's predominantly marine, but because of the situation on the west coast and the aridity and the south wind system, we've got a subordinate aeolian overprint on this, which is actually not so subordinate in terms of effect. It's subordinate in terms of deposit type, but its effect is major in actually making the Namibian megaplacer as big as it really is. So let's have a look at it. Take us through a few steps over here and some of the processes before we discuss the placers themselves. So if we have a look at the Orange River mouth, it's very clear that there's no delta here, and you can see there's a 500 meter height, very wave-driven sea over here. And this is pretty much 360 out of 365 days a year. It's a very aggressive coastline. It's one of the most aggressive coastlines in the world. And the Orange River, therefore, doesn't have much of a chance to build a delta out at all. It can hurl out what it likes out over here, and it doesn't take too long before the wave action, under the influence of the southerly winds, just removes it. And we saw this in 1988 when we had the big floods, that 8,000 cubic meter flood that came down the Orange. It put out a very nice delta over here, and it didn't last more than 6 months, and it was removed. And so this wind that we have on the west coast, the southerly wind regime, is very, very important. We really need to understand it, how important it is. There are some effects of it here. We know there's a linear dune, that's an 80 meter high linear dune. Look at the plume over there. Down in the Spurgebied, you've got many rocks, the dolomites, the granites, the syenites down there are all fluted with the sand abrasion driven by the southerly wind. So it's a long-lived unidirectional wind regime. We can find evidence of it in the famous Boonveld-Schuh escarpment in the Spurgebied, where we've got ages of around about 40-odd million years. So it was kicking and going from then. And the various Sondheim sandstone formation units show that it was at least 4 or 5 times bigger than the current main Namib sand sea back in the tertiary from round about probably the late Oligocene, early Miocene, intermittently through to the Pleistocene in recent deposits. So it's a very important system, and this drives this unidirectional longshore, this northward bound longshore drift up the coast. It makes for an aggressive wave regime as well, but if we have a look over here, looking westwards onto the coast, you can see all the little shadow dunes behind the vegetation here, all pointing one way northwards. And you get up to the central Namib, where the wind is not anywhere near as strong as it is Luderitz and south to Bogenfels and into Namaqualand. And even here in the Walvis Bay area, we have these massive sand spits. This is Pelican, Walvis Bay, Pelican Point, and it's a 17-kilometer long sand spit. So this is where the wind system is slowing down and you're building up your big deposits, but nonetheless all heading northwards out of there. And of course, it's the work that John Rogers did in the late 90s, where he pointed out that the main Namib sand sea that lies between Walvis Bay and Luderitz, 34 square kilometer sand sea that we have over here, is really the sand, the nice clean sands washed out of the Orange River Delta, and it's the displaced delta of the Orange River. And of course, it's a small sand sea. The definition of a sand sea, incidentally, is 30,000 square kilometers, so it makes it by about 4,000 square k's. But it has all the major dune types in the world. We've got star dunes along the east, we have the linear dunes down the middle. Then on the coast, where it's a little bit more windy and more stronger aggressive wind systems, we have crescentic dunes, and of course the Barken dunes, which are the most rapid moving, and they're the ones that dominate the area in the south around Luderitz, Elizabeth Bay, and to the south. Some of these dunes down here move at 300-odd, 400-odd meters a year, very fast moving, whereas the same equivalent dune, the Barken dunes here in Walvis Bay, are only moving at about 5 meters a year northwards. Well, there's a big drop-off in the wind system over here, which is why we have this epicenter of the main Namib sand sea. So how sure are we that these sands are really out of the Orange River, and what is the link, back into this catchment system over here? Well, some good work has been done over the years. Nick Lancaster and Cliff Ollier did work in the central Namib Desert, coming down to the south on the heavy mineral sand compositions in the early 80s, and more recently, Albertina Nokasholi out of Namdeb and De Beers Marine, she's done work on the heavy mineral heavy mineral sands in the different terraces down the Orange River as well. So that work has been done. We've looked at the diamond characteristics ourselves, and it's very clear that we can track some of the neat ones, the very clear ones, back to the Kimberley Pool, Reet River area, maybe Coffee and such like, as well as the abraded stones that I showed earlier that Debbie identified all those years ago. We were able to track really clearly back to the northwest alluvial province. And what's interesting is that our biggest stones that have made it to the terminal placer are not exactly small. On the Namibian side is 246 carata, and it was a nice Cape Yellow Octa, typical of Kimberley. Likewise, on the Alex Bay side, it was a 211.5 carata, again, tends to be your Cape Yellow Octas from Kimberley Pool area. The work that Jeff Harris and Dave Phillips in particular did from 2008 onwards, they looked at the CPX inclusions and diamonds out of the west coast alluvials, and they were able to demonstrate that Namaqualand didn't have the Kimberley signature in it, but Namibia did. It had all the older signatures as well, but it's really interesting that that's supporting the interior source. But really the other way that was done was a good work that Jürgen Jacob did for his PhD, and we were involved with that in the 90s and early 2000s, tracking back the clast assemblages to the different parts of the Orange Val catchment And the most proximal of all the catchment is actually up in Lichtenberg area, where these distinctive yellow chalcedonies and red cornelians come from, as well as the green chrysoprase. And these we find in our Eocene deposits down along the coast. So what we notice is that Orange River system, when it switched from the Kudu Delta into something that was a lot more aggressive, and mainly because of the uplift that imparted that energy to it, it stripped out the interior of South Africa. So we whipped off the Drakensberg basalts, we whipped out the material out of the Upper Harz Valley in Lichtenberg, and the youngest stratigraphy ended up in the oldest marine deposit. So there's an inversion of stratigraphy as we've come down. And when we have a look at our +4 meter, the Eemian High, the so-called B beach and that, we notice that it's full of Makwasi porphyries that come out of the Dwyker that are sitting in the deeper parts of the Orange River Valley, the Middle Orange, from the northwest down to the Douglas area. And so those Makwasi porphyries out of the Dwyker are sitting in our youngest beaches. The Drakensberg agates, which are sitting at the top of the Karoo, are sitting in our oldest marine deposits. So it's quite a neat little story coming out of there. So if we summarize it and have a look over here, what really happens to the Orange River sediment, the sediments from the interior, should I say, hits the coast. You've got this unidirectional wind that takes the sand, moves it northwards away from the Orange River mouth, basically leaving behind a lag of gravel over here and no delta, by the way. So that delta gets totally destroyed. The fines are moved offshore into a mud silt transport path that moves along. We know that from the planiforms and the oil and gas work that's been done offshore Namibia. And then as we go northwards, so the sand sea, because of the aridity, the sands are able to accumulate onshore and build up the sand sea. And interestingly enough, we can track our class, this little signature class. They get smaller and smaller, as do the diamonds, all the way up to Toscanini and that part of the skeleton coast where the work was done in some decades ago. Only about 40,000 carats made it to the top there that we know of, whereas down here, we've already produced over 100 million carats. So it's quite an impressive system, and the distance, of course, a couple of thousand k's to the coast and another 1,000 odd k's up the coast itself. So let's have a look at the placid types that are tied in along this conveyor belt. The conveyor belt. We've had a quick look at the fluvial placids as we came down. We're not going to get too tangled with them because they're not the major hosts in the diamonds in the situation. They add to it, of course, but they're not the major ones. The major ones are really the beaches that we have along the coast over here. And from the Orange River mouth itself, where we have beach barrier placids, this is good work that was done by Spags Fajori, in the accommodation zone, where we've got space to accommodate the barrier placids, you can do that. And they're low grade, but big stone size in the south, close to the mouth itself, which is what you'd expect, because this is where your outfall is. And what we know, what Spags showed here very clearly, is that you have both an outfall from the Orange River contributing to this, and also scavenging off the shallow continental shelf over here, and reworking the stones back into these beaches on shore, the barrier beaches. And as we move north away from here, within about 10 k's of the mouth, we're into bedrock-backed beaches, bedrock cliffs, and these are really the very famous linear beaches all the way up for 100 kilometers north of the mouth. So again, not a small system, a big system, a series of beaches, the famous A, B, C, D, E, F beaches of CDM days, now NAMDIB, and they've been really going since the mid-1930s. Not much left at the moment, pretty much mined out, and what's happening is the shoreline is being pushed in places out. They're creating to get to the beaches that are just below the subtidal levels over there. And then as the sediment runs out, as we go north, because obviously it's a longitudinal jigging system over here effectively. It's a coarser material finding a way like that. You run out of sediment and you end up in the pocket beaches from about 100 odd kilometers northwards through to 300 kilometers north up to Elizabeth Bay and that side of the system. So have a quick look at some of the features of it. Here's the modern example up in the Skeleton Coast, Terrace Bay, the Unyap Delta area. Very nice modern equivalent of what we see in the the Plioplasticine beaches preserved in the old mining area 1 of the Spurgebied. Classic beach profiles, but there's the late Professor Brian Bluck. He was really instrumental in putting scientific rigor into our exploration, and it is great times there. So if we have a look, as I said, most of it you can imagine from 1930s has been hammered, or been mined rather, and so there's not a lot left. A couple of witness sections though that preserve the gravels for us over there. And here's some examples. You have the Plioplasticine examples on the right-hand side, modern examples on the left-hand side. What's interesting here is you have a look at the clasts in here, and these are predominantly Nama quartzites. They come out of the Richtersveld. It's a tough quartzite, and it's the abrasive medium that this energetic marine environment has taken and actually carved the bedrock platforms into platforms and gullies, and this is where the great grades and the great volumes of the diamonds really have come out. And you know, the final bedrock cleaning is with vacuums and manual still today, but it's a very effective system. Here's a seawall behind it, in the background over here, as the guys have pushed the sea back and they've gone down to beyond minus 10 meters below sea level. So it's quite an intense operation, but most amazing places, some of the few places in the world, apart from Congo and DRC potholes, where you can visually see the stones in the gravels in the holes. Of course, that's on the onshore, but also, you know, sea level's been up. We know it's been up to 170 meters, and it's been down to about minus 150 meters. And the marine environment is a lot bigger than our onshore environment, and this has obviously been lots of activity and lots of geophysical development and work done over the decades by De Beers Marine and the other contractors, from both the shallow water, from diver operations, jumping off the shore into the gullies, to the shallow water guys over here, mid-water, down 20 meters to 40 meters, and then into the deeper water where the guys are, or the operations are tackling the minus 120 meters over here. Here's a view of some of the gravels. This is in the Bergenfels area, the minus 48 meter beach. We used the Iago semi-submersible in the late 90s to get down and have a squiz of the seabed, which was really, truly amazing to visually see it and not have to depend on all the remote techniques to see what was happening down the bottom there. So it's onshore, it's offshore, and it's really quite impressive. So what happens as you go up the coast beyond the pocket beaches then? Well, you get the pocket beaches tend to be the south-facing reentrant bays of the harder formations in the Reap and the Pan-African rocks there. But you also have J bays, classic J bays. As you come up the coast over here, we're looking south here, obviously, and as the wave, there's refraction around the bottom end of the bays, you get deposition over here. And because of the aridity and the strong winds, you get the Aeolian transport corridors. Ian Corbett did his PhD on these areas, plus a bit more. And we get the diamonds then being sorted out away from sources, finding away from these type of environments. And it's actually down in this really windy part of the world, in the Bergenfels area in particular, the Mona Bergenfels area, where the winds are so strong that they actually scour the bedrock. When we're looking down here, this is not, it's mined out today, it's been mined about 7 times, is the famous Pomona, Strauss Lager, Edertal, and Marschenthal over here. And these valleys over here have been really just blasted clean by the wind and the sand abrasion. You end up with a deflation placer that's less than 10 centimeters thick. And Marschenthal is the famous place where August Stauch and Professor Schreiber, back in about 1910 or so, went by moonlight and were able to distinguish diamond from quartz in these deflation placers. Amazing story. That's where it is down there, and it's quite something. And then as we go north, here's a really big pocket beach. This is Elizabeth Bay. So mined for many years, both in the 1920s and much more recently, where we had Aeolian placers, where most of the diamonds here is small, and they're down and been reworked by the wind, or redistributed, should we say, by the wind in these environments. And that's what that's really how it all started. It started back in 1908 when these mega ripples were being blown and moved over the railway line between Luderitz and Aus, and a railway worker, part of the team under August Stach, Zacharias Lawala, he used diamonds from Kimberley, and he actually recognized the first diamonds over here. So right at the terminal end, the distal end rather, of the terminal placer, is where the Namibian placer started to become unraveled. So it was first started with these really small stones sitting amongst the grits and the small pebbles. I might add here that the Aeolian component gets up to 12 millimeters, which is well in the pebble range, and you can get 4-meter grits flying at 2 meters in those southerly winds without any problem. And that's really the early stages there. That was the start of it, 1908. And basically, the people moved south, following the diamonds southwards until 1935 or thereabouts, when they found them at the mouth of the Orange. And on the Namibian side, obviously 28 on the South African side. And so if we have a bit of a summary then, and work backwards from the Orange River mouth, you see that the average stone size coming down the Orange is 1 to 2 carats a stone. It then tails off very nicely north of the Orange River mouth, of the outfall, which is what you'd expect. Here are some Orange River stones from Dick Barker's operation at Winnis, 53 carat over there, just for scale. And here are some stones up at the top end of the system at Elizabeth Bay over there, running at just about 0.18 average stone size. So we've had these stones moved up the coast, small stones in the Eocene, bigger stones later from the Miocene onwards, and distance 300 kilometers up to Luderitz, but you can add another 1,000 k's to get up to the Skeleton Coast, or 750 odd to get up to the Skeleton Coast. So it's, again, a big system over there. So what do we need then for this to really make a decent diamond megaplacer? What have we learned from this Namibian megaplacer? Well, I think firstly you need a good craton, or a series of cratons, but usually a good craton. You need to have lots of kimberlites on that craton. It's pretty useful to have a long history of kimberlite intrusions, and we've got that on the Kaap Val from Cullinan through to Kimberley. You want to be able to spend a bit of time keeping them on that craton, minimal loss. Well, the Twaka had a bit of a scrape off, but didn't really do that much. And then if there's a chance to repeat and rework them in a couple of little interior basins, it's useful. But then what do you do with it to get it off that craton? It doesn't really build up huge alluvial deposits. What you need to do is you need to have that drainage basin with a high percentage on the diamondiferous craton. And that's where the Orange Val comes in. It's 36%. You take the Congo, it does quite a nice big river in that, but it's only 10% on the craton. That's not as useful, certainly, as 36%. You then need to take that drainage basin and uplift it, give it some energy so that it can strip out your craton and bring the material down through to a terminal placer. And once you can bring it into a terminal placer, you need to be able to fractionate that sediment, sort it out, effectively sort it out with nature, put it on a shallow shelf where you've got sea level rise going backwards and forwards, so it's raking it. We know that the wind belt stays roughly, the high energy wind belt stays roughly 20, 25 kilometers parallel to your coast. So as the sea level's gone up and down, so that wind has just moved things away, takes out your fines, it does your overburden stripping for you in effect, and it leaves you behind with a gravel lag. And it's very useful to have a whole bunch of gravel that's coming down here so that it can cut your platform, cut your coastal platform, the good work that Johanna Jacob did and her work that it showed over Mike Millard on the pocket beaches, showing that it's very important to have that abrasive medium to cut your gullies for you. So it really is, if you look at that combination, it's quite a combination that you need to get to a reasonable megaplacer. And so what have we got then? At Namibian megaplacer, 100 million carats have already come out. And, the big story is what's left out here in the ocean. Is it another couple of 100 million? Is it 500? Or is the billion that has been predicted by some of the earlier workers. I would say that, looking at the beating and getting to a 95% gem quality, we at least had a minimum 500 million starting over here. And and I think that's the challenge as the technology improves for taking out the material and taking out the offshore, as it were. So the Namibian terminal megaplacer certainly sets a standard against which to compare, and we certainly spent a bit of time comparing White Sea and Cambridge Gulf, White Sea of Russia, Cambridge Gulf, Laos, and a few other places, and even our good friend up in Marangi, which has over 100 million carats, but only 10% gem quality. So it's certainly a special megaplacer, the Namibian one. It's probably an order of magnitude more than the original definition of 50 million. And it certainly leaves its Namaqualand cousin down there in the shadows, where it's only about a 50 million odd megaplacer in itself. So thanks very much, folks. That's it for today. And I'd just like to end off with a thanks to a lot of the old toppies who've been involved. I mean, quite a few of them are on the call now, and two of the guys that I certainly interacted with, Mike and I, in the 90s and earlier, Dick Barker and Brian Black.
Thanks, John. Are you there, Gert and Henny?
Yes, we are here.
Yes, I'm here.
Any questions, guys?
Okay.
You can unmute yourself by holding down the space bar and then just speak up. Otherwise, stick up your hand if we are talking too long.
Okay, thanks, John. That was excellent. We really appreciate that work, and yeah, credit to the characters like Dick Barker. I mean, you might want to give a little bit of background about the character that he was and all the things he did as well.
I think, if I may, Dick never finished school. He came from a digging family, grew up in the Bloemhof area, but he had a passion for diamonds, particularly for alluvial diamonds, although he had a crack at the kimberlite at Postmasburg and Makanyani. But Dick really was, he just believed in stones, and I think he went through about 5 fortunes in his time. He put allowed a lot of context in what he did on the Vaal and the Lower Orange when he went across to Unas. He was very, how can I put it? He was very accommodating in terms of allowing access to what he was up to. And you must remember that those of us who all worked for De Beers before, we know that limited access. You guys have said it before. Dave Apter in his talk, John, you said it. We had limited access to the actual product itself. And it was guys like Dick that actually allowed me to see product openly and taught me a lot about the points of the product. And so there was Dick on one end, and there was Brian on the other end with his academic awards, Emeritus Prof, all the rest of it. And those two guys clicked. And we shared a lot. Well, they shared a lot of their knowledge with us. Brian from the academic on the beaches and the rivers, and Dick on his on the diamond side. And it really helped, to put things together. And as I say, Brian kicked our backsides with good scientific rigor in our exploration programs. And I think that really helped a lot. And it helped us in Central Africa when we evaluated Congo, Spags and myself, Mike, in 2005 before I left. And looking at Angola in the late 90s as well. So it was good.
Yeah, I agree, John. I mean, he was incredibly insightful, even though he didn't have formal education. Yeah. He was extremely insightful. And likewise, I mean, I saw my first diamonds courtesy of Dick Barker. Anyway, let's have some other questions.
Can I make a comment?
Rennie.
John, can you hear me?
Yes.
I'd just like to say, nice to see you, John, after all these years. I think it must be 35 years or something since we met on the West Coast. But thanks very much for putting together your excellent synthesis of all the different factors that led to that unique deposit that occupied so much of our lives. Just a comment on your source to sink model. I see on the flippant side you represented the sharks there. I don't think they were too into that model, but you left
Yeah, we all have to have some weakness there, Ronnie.
So Ronnie, when can we get you to give a talk from a more management perspective and how this big organization works so successfully?
You're not going to get me giving a talk on anything because I don't have any I don't have any diagrams or images or anything to do with it. So I'm not going to give a talk. I'm very happy to listen. You've had some excellent talks on diamonds. You guys seem to know it all. Well done.
Thanks. Anyone else?
Hi, John. Mike van Staden here. Hello.
Go for it.
Okay, hi.
Hello,
John. Nice to see you, John Ward. Just a few questions and comments, maybe. I think probably everybody knows that those areas have been seriously mined out on the land side. Is there actually still hope that we can one day go back there and mine some stuff? How's the exploration going in modern days? I remember down in the Makulan side, you have the megalodon and big features like that we used to have a look at from a geometallurgical point of view, but in the De Beers days, just before I left. But is there still hope for those areas that it can one day become, it's obviously gone over its prime, but surely there must be something there that people could still target? Any ideas there?
Michael, hi Mike, no, it's good to see you, hear you. I think, on the Namaqualand side, it's a little bit different because once you move south of Pocock Bay and that side, you move into a different diamond population with a smaller stone size. And that's going to be our challenge, I think, for the future working in the diamonds, is that those small stones are going to battle in the market. So Megalodon and those very deep channels that they've got down there are really populated with the average stone size of 0.25. And that's going to be a tough call, I think, on the deeper ones. Obviously, there are always shallower tributaries that have been missed in the geophysics or whatever over there. I'm thinking of a place like Albatross and those places. They may come to the fore, but the big advantage that the orange has is that it's got a much bigger average stone size, and that's going to help. In terms of exploration, Jürgen Jacob and his team on there, they've done an excellent job, I think, and I think that follows on from the earlier work. It's nice to have Ronnie Hazel on the line because it was really Ronnie and Doc Stockton in those early 1980s that allowed me the first visits there. And, there's been ongoing really good work on the Namibian side. And I think it's going to be difficult to find leftovers. There's been some very good geophysical work done recently under the town, under the monument, and they've recognized some of the proto-orange deposits there, which is good news. But again, it's at depth. One would have to work out what the economics are for that. But I think Namaqualand has a tough call ahead because of this average stone size, given its placer type. It came down, it's much earlier, it's a pre-Kimberley population, and it's a different river system that was not quite as energetic as the later orange. So therefore you had a smaller population down to the coast.
Thanks, John, that's great.
That's very interesting.
Yeah, and maybe if I can just add there, it's quite interesting, John, and you'll know it better than me, but on the south side of the orange, looking at Alex Core, there's clearly pockets and remnants that guys who are working somewhat bigger, people like Courtney Corneliuson and a couple of others are picking up good local deposits, and particularly in the sort of surf zone where the high energy zone where people haven't been able to get into. I mean, just for interest in this market, Alex Core have actually just had a tender and achieved $600 a carat. So and they're seeing more regular big stones in these sort of local pockets. So if you go scavenging and find them, they're still finding some quite decent populations of diamonds, which give you better dollar.
Now, John, for sure. That 20k south of the Orange River mouth into the Alex Bay side is good, is part of the Orange River outfall, and the good stones there. You know, the big, and there's less sand, funny enough, on that southern side. So the big question here is to be able to fight the energy of the sea. You know, those sea days become important. But what is interesting is that guys are getting more clever. You know, and there's better geophysics. The swap bathymetry is helping a lot. And I know Jürgen Jacob and his guys on that side have got a specially kitted out a vessel that can actually now get into the breakaways at 500 meters to a kilometer zone. High energy area has always been difficult to deal with. And, you know, when they've done lots of work to actually get into that part of the world. There's also a blanket. There's a bit of Ronnie will know it well. It's the acoustic blanketing layer on the Orange River Delta. It's a fine-grained layer that's got gas in it. It's a bit difficult to see through, but it's Orange River sediment, and it's going to be covering some. So if you can get to the fringes of that, where it's not so thick, you've got a chance to get underneath into virgin ground. So it's exciting. It's amazing that placer just keeps on producing. You know, I mean, even that land-based thing, the guys are still going. They're still producing from the land all these decades later.
I guess a lot of it's in the technology, Mike.
We've got Chris Hatton there. Chris.
Hi, John. Thanks for the talk, eh?
Hi, Chris.
John,
Thanks.
John, are there lead zinc diamonds in the system? And if there are, when did they appear and when did they disappear?
It looks to us like they get down to about the middle orange, eh? And once you've got to go through the big ball mill of the Kralbys, they're going to battle to come out. The plus hundreds that come out on the coast are, or should we say, the most of the bigger stones are, which is not always everything, but they are the Kimberley Pool, John, Chris, they're the type ones. Eh? Type twos they certainly down Hopetown way. The pinks that have come out of there and the type ones that Lyndon de Malon's taken out. I think the type twos that Lyndon's taken out, those are the Lesotho stones. It's not just Letseng, you know, Carl's also contributed, got more pinks than Letseng, and also got a few decent type twos itself. So Carl's the most eroded of the pipes out of the mountains there. So it's probably given the biggest contribution to the Vaal Orange system.
Okay. And when did they come into the system?
They came in. They've all come into the system from the Eocene. We've got Drakensberg basalt agates down in the Bogenfels Eocene deposits. So from 42 to 50 million is when they were starting to come down, Chris.
Okay, thanks, John.
Okay.
I agree with John. In fact, if anyone's interested, there's an amazing profile or portfolio of big diamonds and as John says, the coloured stones in the Hopetown Douglas Leg. It's just amazing the goods that came out or have come out and still come out of that area.
John, can I ask that? Is the Orange River system, is that the only megaplacer in the world, or are there other megaplacers in the world? I think in particular of Brazil, or all the major rivers that they have down there.
They haven't lumped together into a 50 million plus deposit. You know, funny enough, they haven't quite produced the same number. The next closest to this are the alluvials in Angola, which are running at about 80 to 85% gem, and over 100 million carats have come out, but spread out over the river systems and those plenty of proximal sources up in Angola. So to get a megaplacer into one place, as we have not been able to find it. Namaqualand just makes it on 51 million carats, and then it's the Namibian portion, or the Orange River. Call it, there's a Namaqualand placer and a Namibian placer. But the other places, no. The Marangi would have made it because it's produced over 100 million carats, but it's 10% gem quality. That's at Mkondo 1,100 million year old combination placer and a sub-recent weathering out of that placer.
And nothing in Siberia.
We looked up there, and in the rivers, not bad, but certainly not 50 million at this stage. Maybe it is there, and it just hasn't been properly taken out. We looked into the White Sea as well, but it doesn't seem to have the same conditions of concentration and reconcentration over 40 million.
Hi, John. Can I ask a question?
Yep.
Hi, John. It's Rats here. Just wanted to know your thoughts on why you don't think there's any mega places on the east coast of Africa, because we've got some big systems, Limpopo, Savi, Zambezi, these big rivers also draining some really good source areas, including some of the paleo alluvials like Morangi. And there's evidence, I guess, in the Savi sort of mid system there for some gravels and things like that. What do you think the factors are? Why do you think nothing's been preserved, or is it just we haven't found it yet? Has it been buried? What's the story on the east coast of Africa?
Hi there, Rats. Good to hear you, lad. Yeah, no, I think the problem with the east coast, Rats, I went down and looked at that Savi stuff in Mozambique, and there actually isn't such a big source, believe it or not. It doesn't come all the way through. And the other problem is once you get into the east coast, you build up those dune cordons, and you end up with not removing your material sufficiently easily. So you end up with a lot of dune cordons. So heavy mineral sands wise, the east coast is great. Richards Bay minerals, even the mouth of the, even the Savi, those beach or the strand lines up the Mozambique coast are very impressive from a sands point of view, but they don't seem to have segregated out the gravel into the gravel beaches from the little bit that I know. Once you talk about the Zambezi as well, I was there many decades ago, and it's just not sorted enough, Rats. It's basically still got a lot of the fine sediment that's in with it. That's at least what I would put forward on the stuff that I've seen so far.
Okay, that's great. Thanks very much, John, and thanks for a great presentation.
And John, doesn't gradient also play a role there? Those rivers, if you look at the gradient compared to, say, the Orange Vaal.
John, you've muted yourself. We can't hear you.
We've lost him altogether. He's off the system. We've lost him. Okay. He's dropped his internet.
I see. So we're just looking at the light picture of his. While we wait for him to come back, John, one of your early slides on your section, you show some skull and crossbones at various places. Is it dead or is it dangerous, or what is the significance of those little sketches?
No, the skull and crossbones, you're not going to find too many stones in there, Danny. So basically,
dead areas.
Basically, dead areas, yeah.
Okay. Now I just thought, to some other significance, having seen the sharp.
No.
John, maybe I could ask a follow-up on, you mentioned Morangi a couple of times there, these basal proterozoic, the sort of paleoalluvials. Obviously that was a huge surprise, and in terms of exploration, not just in Africa, but across the world, do you see any of those perhaps approaching megaplacer sort of status, and if not, why not?
Yes, I was fortunate enough to have a look at the stuff in India, which is the closest. We've got really three main areas that, and there may well be more, as you can imagine. But the three main examples are the Eastern Ghats in India, where you've got the drainage off the Kraton there. There's some decent stones, as we well know, and we had a Proterozoic placer developed in a place called Banganapalli. But again, the source areas seem to have had a nice type 2 stones in the Golcondas type 2s, the original type 2 stones. They're just not enough. Just the source areas seem not to be good enough, and the modern scree alluvials and in the conglomerates there seem to be lower grade. The other places, obviously, here in South Africa, with the northwest alluvials, where we have a similar situation. And again, the Dwaika that was coming in just wasn't high grade. And I think what makes Morangi different, Rats, is that in spite of a lot of the people think, and the abrasion, is that I think your sources in Morangi were contemporaneous in age. In other words, they were Cullinan age kimberlites at a time of a Cullinan age shoreline, and they were close by. And that made a difference. There were no big rivers to dilute it or to hide it. It basically came short distance, short reach, not much sediment in there, into a Proterozoic shoreline with a Proterozoic tidal range, which we know from the oil and gas industry is somewhere, big, always were big, 10, 12 meters. So lots of sorting, easy sorting in a fjord, in a restricted embayment situation at Morangi.
Okay, that's great.
Thanks, Michael Staden has another question for you, John.
John, sorry, me again. Just an interesting one. Many years ago, it was sort of the early 2000s. We were called in from the De Beers side, head office side, to come and have a look at Kooinas, which is now again down in the west coast. The place called Kooinas, where they had some operation going as well. And I'll never forget that that was some of the worst clay pockets that I've ever come across. And we were, as metallurgists, we were roped in to come up with some solutions to try and, obviously this material had grade, but to try and get the diamonds liberated from these clay balls was quite a mission. And we had to look at some various technologies, but maybe from a geological point of view and understanding those systems so well as you do, how do these clay pockets, if you like, because they were huge pockets in places, maybe a comment or two from your side on this clay and how that actually comes to be. Thanks.
Yeah, okay. Well, that's a very interesting story that dates back to Peter Bonaccorsi's days in 1966, 1967. They had their program going in Namaqualand. And there was an Australian geologist, Pino tells me, that said he wanted to test the clay underneath. And they said, no, it was going to be useless, Anyway, when Pino came back, they were living in little wooden shacks at Kooinas, and the light was still on, 10 o'clock at night, which was very unusual. When he went there, the guys were still counting the stones from that day, because the grades in those clays were over 5,000 CPHT. Now, those clays were in the channels, in these megalodon equivalent channels, and there's been lots of discussion as whether they were Cretaceous channels or a little bit younger. But effectively, it's the so-called African surface. There is of Tim Partridge and the late Tim Partridge and the like, is there in Namaqualand, and it's underneath the silkreeds. And you get a kaolin clay formed, which can be either in situ or reworked into those fluvial systems. And it's an incredibly mature kaolin clay, and that's what your stickiness was in those places. And those channels around Kooinas, Swartlinkies and that are actually choked with that clay. And it's it's a metallurgically, Mike, it's a mean thing to deal with, but it's part of that weathering profile and that antiquity. We think, some of us believe, that those channels are actually Oligocene in age. They've got Cretaceous microflora in them, but they also have some tertiary pollen, early tertiary Oligo-Eocene pollen in them. So it's more likely to be part of the Oligocene low. We had a big low stand, sea level low stand in the Oligocene over a couple of million years, maybe 7 million years, where the sea retreated down to -150. And that then developed these drainage systems that reworked some of those early Namaqualand beaches into those channels.
Okay, thanks very much. That's very interesting. Yeah, still remains a problem though.
What's wrong with the geologists found
climate change.
The geologists found it. Why can't you get them out?
Yeah, that's the problem, huh? Sometimes our hands are cut off a bit. No, you can probably get them out, but that's not cost effective. Yeah.
John, just a comment maybe on some of these paleoplacids that we spoke about just now. In the Russian placids in the north of Siberia, those mines have only been going for a much shorter time than their kimberlite mines. But a lot of those diamonds are coming out of Triassic sediments and have been reworked twice already. So it's that reworking what you're talking about is quite important. But those alluvial mines are producing now something between 4 and 5 million carats per year. So in probably 10 years or 20 years, you may want to start thinking about calling that a mega placer. And the other area that's of interest is perhaps the Roraima area in northern Brazil, Venezuela and Guyana, where diamonds have been coming out of those Proterozoic sediments at quite a rate. And there's been a lot of mining going on in all these countries. I have to look at the total production, but I guess those sediments would contain well over 100 million carats in the sediment, but they are just too low grade to mine. So you have to, they only economic once they've been reworked out of those Proterozoic sediments. So there are interesting areas that contain large amounts of diamonds, but as you say, you need to go through that process of reworking and upgrading them to really make it economic.
Yeah.
Oh, thanks very much, Mike. I think that's the reason why Marangi is so special, because the Proterozoic conglomerate is running at about 50 carats a ton. Yeah, I mean, it's already been upgraded, and I think that's because of that supply situation. Yeah, but I think the Russian areas is certainly going to get on the playing field soon. I agree with you there, Mike. Thanks very much for that.
Well, what about just a comment on we're talking about the Angolan story, but Chicapa, the Chicapa Triangle has produced some 100 million carats out of alluvials. And those are not, okay, they're small sizes, smaller sizes, I guess, but they're still quite high value diamonds. I mean, not necessarily industrial standards. There's a high percentage gem quality in there.
Yeah, but they run at about 75 to 80% in the Chicapa Triangle, Mike.
Yeah.
Yeah, so it doesn't, maybe we need to redefine the 90 or 95% top threshold, maybe.
Okay.
Yeah, and then a little tongue in cheek, why haven't the guys in the Wits looked more for the diamonds that we also see in the Wits? Maybe you got to reprocess some of those dumps, Mike.
They crush the stuff, John. That's the trouble.
Yeah, that's the problem, yeah.
Okay, Henny, are we done?
Yes, thanks. Tony, Anthony touched on that, on the East Coast, which just brought up an interesting point. So one could probably say that there are enough diamonds, they just haven't had all the factors reworking them to a mineable grade. So they could be there, just not in a good quality state. Okay.
Right. Thanks, John. Thanks, everyone, for attending. Thanks, Henny and Gert, for sharing the load on the Zoom management. Really appreciated, and we look forward to more discussion and next week's talk. And from this extreme, we'll be going back to Jimmy Davidson and his micromine at Helm. So we look forward to that talk as well. Thanks, everyone.